Through high-temperature baking, a glass tube is instantly transformed. It is split into two, becoming the glass seal we see here. A copper lead wire is then inserted into it. Each shell undergoes its own heating transformation. Every step is crucial. Each process is a crystallization of wisdom. This is the white incandescent lamp, a household item that once made great contributions to humanity. As society developed, its presence became rare. However, decades ago, it was an essential item in every household. Today, we will delve into the process of making white incandescent lamps. This small item costing only a few dollars holds great mysteries inside. With the glass tube cut, the production process officially begins. The glass tube is heated and solidified at the top to prevent cracking. This indirectly increases the stability and hardness of the tube. Each one is uniform in size. The tubes are rotated in the machine and transported to the next stage. These tubes are used to protect the lamp filament and ensure airtight sealing. Through machine transportation, each tube glides freely along the tracks. They line up, ready for the insertion of lead wires. Such fragile glass operates smoothly, thanks to the machine design. It appears that the machine design is highly precise. After the lead wires are inserted into the tubes, these wires become the two thick copper wires inside the lamp. They are used to secure the tungsten filaments. The fine glass tubes visible here are called exhaust tubes, used to remove air during the lamp making process. This is because tungsten is sensitive to air. If your home's white incandescent lamp turns black or breaks, it could be due to air leakage. The exhaust tube is placed into the glass tube and heat sealed. The red metal wire in the center is the filament. Once the tube is secured, it can protect and isolate from external contact. The glass seal is rapidly cooled using gas. The installation of the exhaust tube and core pillar is complete. The longer part of the glass tube serves as the air extraction port. The shorter end of the exhaust tube is the core pillar. Once the air is removed, the long exhaust tube is cut and sealed through welding. The glass tube rotates continuously, ready for testing the tube's durability. The purpose of testing is to check for cracks. If it doesn't crack under pressure, the tube passes the test. Next, the internal lead wires are shaped. Lead wires can be made of various materials, but copper is the most commonly used. In the next stage, the filament assembly begins. The filament is noticeably flexible and extremely thin. What we see here is tungsten wire. Thankfully, this process is mechanized. Otherwise, manual assembly would require magnifiers. Before mechanization, this was all done manually. Simply installing the tungsten wire isn't enough. A support bracket is also an essential component. After heating, the bracket is fixed onto the core pillar. This is the structure shown here. It effectively prevents filament vibration. As seen earlier, the tungsten wire is highly elastic. The current operation involves fixing the filament onto the support bracket. This also helps extend the filament's lifespan. Once the filament is secured, it needs to be reshaped to become smaller. What will appear next is the reduced form. It's essentially bent to be smaller. At this point, the filament installation is complete. The machine then transports it for manual inspection to check the filament's completeness. Any incomplete components are sent back for reprocessing. Next, the process moves to the next stage. The assembly of the white incandescent lamp base. A small amount of white liquid is applied to the surface of the core post. After the coating, it is transported forward for further testing. The internal lead wires undergo subtle changes. Small metal pieces slide to the front of the machine. These metal pieces are mainly placed at the glass seal. This is the structure shown here. With the basic components fully assembled, the process moves to shell installation. Each glass bulb is placed on a heating station. A glass shell is placed outside the bulb, firmly encasing it. This step is also the sealing process. The heating treatment shown next processes the bottom part. Each bulb undergoes the same operation. The bottom is softened, and excess material is removed. The shell and bulb are fused into one unit. This ensures airtight sealing, preventing air from entering. But this is not yet the final product. The internal air still needs to be extracted. A vacuum state must be maintained. Not a trace of air is allowed inside. The pink air extraction device resembles a large lollipop. After extraction, the bottom is sealed. This ensures a complete seal. Now, the interior of the white incandescent lamp is vacuum sealed. Each lamp is carefully inspected manually. The lead wires are straightened during the inspection. Two small rollers gently straighten the lead wires. These two lead wires conduct electricity to the filament. The metal cap is now ready for installation. The two lead wires protrude outward. The lamp undergoes a final brightness test. Once the cap is secured, the lamp's brightness is tested. If each lamp lights up, the assembly process is successful. Next, the heating and curing process begins. Each white incandescent lamp is placed on a rotating heating rack. This involves high-temperature baking. Only after high-temperature heating will the cap fully fuse with the lamp. This step removes any excess filament. A drop of liquid is applied to aid the welding process. This appears to be aluminum solder. Aluminum indeed has a high melting point. With a light touch, the lead wires fuse with the metal cap. The top is also essential. It requires welding as well. The welding technique differs from that used for steel. The top uses vertical welding. At this point, the entire bulb production process is officially complete. But why doesn't this white incandescent lamp use transparent glass? Each lamp is tested one by one on the test platform. Only lamps that pass the brightness test can leave the factory. The above is the production process of white incandescent lamps. This is Tianjian Nongren Xiaonyo. Thank you for watching.